I yell?
Yes, it would.
Oh,
Okay,
sick.
so we're going to look at this reaction here. So in this reaction, because we went over the 5 kinds of reactions yesterday, we went over synthesis, decomposition, single replacement, double replacement, and combustion reactions yesterday, okay? And we learned how to write them and how to balance them, okay? So we're going to look at this one here, okay? It starts out with chlorine gas, okay? So I'm just going to write out, remember when we're writing it out in words, it's just a naming exercise. So chlorine plus, and then I've got this ionic compound, sodium iodide. Okay, gives me iodine as an element and sodium chloride as an ionic compound. All right, so that's what it would look like, and that's what we were doing yesterday when we were writing them out in word form. Okay, the other thing you were asked to do was to identify the reaction type. Okay, so this reaction type has an element reacting with an ionic compound. There's some switching or replacing going on. You get a new element and a new ionic compound. So what reaction type was that? That is a single replacement reaction. All right. Then we have to balance the reaction. Okay? And other than combustion reactions, which had their own set of balancing rules, okay, our general rule is look at the biggest number and balance it first. Okay? The biggest numbers are 2, and they're for iodine and chlorine. It makes no difference in this example which one I pick. Okay? So I'm just going to start with chlorine because it's first. So there are 2 chlorine atoms on this side. But on the product side, there's only 1. So what do I need to put in front of sodium chloride? A 2. All right, so I put a 2 there. When I do that, my chlorines are now balanced. There's 2 on both sides. But now there's 2 sodium on the product side, and there's only 1 over here on the reactant side. So what do I need to put in front of this? Okay, when I put the 2 there, it balances my sodium and gives me 2 iodine. And, always a good sign, there's 2 iodine on the product side, and now the reaction is balanced. Everybody good with that? Okay, so that's what we were doing yesterday. Okay, I want you guys to try the last 2. So you're identifying the type, writing it out in words, and balancing it. Right? And I'll give you a little hint. They are very similar, those 2 reactions. And the last one, the balancing is really easy. Okay, so for our second to last one, we've got calcium chloride, which is an ionic compound, reacting with another ionic compound, sodium carbonate. Okay, and that's going to form another ionic compound, calcium carbonate, and sodium chloride, again, another ionic compound. All right, so every single one of the compounds in this reaction is ionic. Okay, every last one of them. And all that's happened in this reaction really is that the metals have switched partners. So what reaction type is that? Not single, but double replacement. Right. Okay. In a single replacement, we have an element and a compound, like the reaction before. Okay. In a double replacement, we have 4 ionic compounds. Okay. All right. So now that we've got that, now we need to balance it. Okay. This is where we don't want to get confused. Okay. When I look at CO3, how many CO3s are there? 1. Okay, we don't want to let that 3 confuse us. CO3 is carbonate, it's a polyatomic ion. Okay, there's no bracket around it, so there's 1 carbonate ion on this side and 1 carbonate ion on the other side. They're already balanced. Okay, I was looking for the highest number and that's what I saw. Okay, the next highest number is 2. Right? Sodium is a 2 and chlorine is a 2. It really doesn't matter which one I start with. But on this side, there's 2 sodiums, and on the product side, there's only 1. So if I put a 2 here, that'll balance my sodium and give me 2 chlorines, which I need over here, because there's 2 chlorines over here. Okay? There's 1 calcium on the reactant side, 1 calcium on the product side, and we already checked the carbonates, so that 2 was the only number I needed to add in order to get this reaction to balance. Everybody all right with that one? Okay, so last reaction. What kind is it? It's also a double replacement reaction. Everything's ionic, sort of. Is water an ionic compound? No, but we wrote it that way. Okay, so again, water's the exception to every rule. Sometimes we write water like this when it's in a replacement reaction. Okay, we write it like it looks like it's ionic. right? But it is a double replacement reaction, okay? And when we're writing it out, we're going to have hydrogen chloride, okay, is reacting with potassium hydroxide. And that's going to form water plus potassium chloride. Okay, so like we said, everything's an ionic compound. Okay, so it's a double replacement reaction, and I'm done balancing. Right, it's already balanced. If you don't see any little numbers, everything's a what? Everything's a 1. Okay, since there's no little numbers, I don't have anything that's out of balance because everything is a 1. Okay, so I don't have to do anything to this, it's already balanced. Okay, is that ringing a bell from yesterday? Right, we're going to be basically practicing that today, making sure we kind of understand how this works. Okay, because on Monday, next week, we're going to be doing a lab on chemical reactions. Okay, we'll be mixing some different combinations of things together and seeing what happens, and at that point, we should be looking at being able to predict the products of a chemical reaction. Right, so we're going to be looking at reactions today and tomorrow. We'll look at predicting reactions on Thursday, and we'll start doing the pre-lab stuff on Friday. Okay. All right. I want you guys to try the first 3 here. Okay, so I'm going to give you the first 3. Okay, and for these ones, okay, again, write it out in words. Okay, identify the reaction type and balance it. Okay, same as we were doing before. All right, so for our first one here, okay, we have nitrogen with oxygen, so both non-metals. What kind of compound is that? It's molecular, so I'm going to have to use prefixes in the name. This is going to be trinitrogen dioxide. Okay, and it's the only reactant. Okay, we've got the arrow right after that. Okay, our products are 2 elements, nitrogen and oxygen. All right, so this compound is breaking down. What kind of reaction is that? No. Simple decomposition, yeah. Okay, so there's single replacement, simple decomposition. I never use the word simple, I just say decomposition. Okay, it's a decomposition reaction, it's breaking down. Okay, so this will be decomp as the reaction type. Now I've got to balance it. Again, we want to go with the biggest number. The biggest number is 3, and it's attached to nitrogen. There's 3 nitrogens on the reactant side, but there's 2 on the product side. What number can I use to balance 2 and 3? 6. Right, the lowest common multiple of 2 and 3 is 6. So if I get 6 on both sides, it'll be balanced. So I'm going to put a 2 here, because 2 times 3 is 6. I'm going to put a 3 here, because 3 times 2 is 6. Now my nitrogens are balanced. There's 6 on each side. But putting this 2 here gives me how many oxygen? 4. Right. What do I need to put in front of it on the product side? 2. Right. Now the reaction's balanced. Okay? Everybody with me on that one? Okay. How many people are done number 2? Okay, let's go over that one then too. All right. So on number 2, okay, I've got an element, calcium, which is a metal. Okay, and it's reacting with an ionic compound, iron and chlorine together. Now, this isn't just iron chloride. What is that one going to need in it? It's going to need a Roman numeral because iron has more than one possible charge. Okay, chlorine's always a -1, so there are 3 negative charges, so this iron must have a charge of +3. So iron 3 chloride. All right. When that reaction takes place, I'm left with these products: iron as an element and calcium chloride, which is an ionic compound. All right, what kind of reaction are we looking at here? Single replacement, right? I've got one element, okay, replacing one part of a ionic compound. All right, so that'll be single replacement. Okay, right now, the only thing that's out of balance is chlorine. Okay, and it's also the biggest number. So I'm going to start over here where there's 3 chlorines, and there's 2 chlorines on the other side. So just like our last one, the lowest common multiple is 6. Okay, so I'm going to put a 2 in front of this to get my 6 chlorines on this side, and a 3 in front of this to get 6 chlorines on the product side. When I put that 2 there in front of the iron, it gives me 2 irons as well. So what do I need to put right here in front of iron? Okay. when I put the 3 in front of calcium chloride, it gave me 3 calcium, so I got to go back and put what in front of this? Right, and now it's balanced. Okay. All right, how many people have done number 3? All right, let's look at that one too. Okay, number 3 is a bit trickier. We've got this stuff, and it'll be hard to name because I don't remember what the prefix for 14 is. Okay, so that's okay. This stuff is actually called hexane. Okay, that's its actual name. You name organic compounds like this, hydrocarbons, you look at however many carbons there are, put the prefix for that number, and end it in ane. So hexane, or the stuff that's in gasoline is octane, it's C8. Okay, so you just keep naming it like that.
Water.
Yes. Okay, so we've got hexane, and it's reacting with oxygen. Okay, and it's going to produce carbon dioxide and water. All right, we only have one reaction type whose products are always carbon dioxide and water. What is it? The combustion reaction. Right. Okay, now combustion reactions have 2 special rules for balancing. What are they? Balance alphabetical and the rule of 2. Right. Okay, do I need the rule of 2 for this one?
Yes.
Yes. Okay, I apply the rule of 2 if I have an even number of carbons. Okay, 6 is an even number, so I do need to start with a 2 in front of this. All right, now I can balance alphabetically. 2 times 6 is 12. All right, so I'm going to put a 12 in front of carbon dioxide, and now my carbons are balanced. Okay, 2 times 14 hydrogens is 28. So I got to go over here and go 14 times 2 is 28. Now my hydrogens are balanced. Now I balance my oxygens. Okay, I have 12 times 2, so 24 oxygens here, and I have another 14 oxygens here. Okay, 24 plus 14 is 38. Right? What times 2 will give me 38? 19. Right? Now my equation is balanced. All right, is that ringing a bell? Okay, so the combustion ones are a little bit tricky because they're a bit different. All right, so we got a few more here. Okay, but the last one is different. Okay, this is more like, number 6 is more like what I would give you on a quiz or a test. You're getting it in words. You have to put it in formula form. If you don't get the formulas right, will you get the balancing right? No. Okay, so if you're working on that one and you can't get it to balance, then you probably have one of the formulas wrong. Okay, just so you know, that's usually a sign that one of your formulas is wrong. If you're going back and forth and you just can't make it balance, it's usually that one of the compound's formulas are wrong. Okay, so keep going on these. Okay, so for 4 and 5, same as what we were doing before, write it in words, reaction type, balance. Okay, and then for number 6, write it in formula form, reaction type, balance. All right, we should be able to get through those definitely here this morning. All right, so for number 4, okay, we've got 2 elements, so one of them being chlorine, okay, and the other one being lithium. Okay, and they're going to combine to form lithium chloride, an ionic compound. Now, question for you on this one. How did I know to put the lithium first when I wrote this compound? It didn't come first in the reactants. Why did I put it first when I wrote the products? Right. Metals always go first in an ionic compound. Guys, when we get to the point where we're predicting the products of a reaction, I will catch half of you on that trick on a quiz. Okay? If I write a synthesis reaction like this one is, okay, and I write it like this, nitrogen plus calcium gives me what? Okay? Half of you will forget and you'll go NCA and you'll do the drop and swap with N first. Okay? It's just a little trick. Okay? But it's a little trick to check and make sure you remember, okay, that metals always go first in ionic compounds. Okay? So I'm warning you about this trick now. If I burn you on it later, okay, then I'm going to say I told you so. But remember, fool me once, shame on you. Fool me twice. Okay, so I don't want anyone to get caught on that twice. I'm warning you now. Okay? All right, so this is going to be a synthesis reaction because we have 2 elements combining to form a single compound. Now we need to go back and balance this. The only thing that's out of balance is chlorine. There's 2 on this side. So I need to go over to the product side and put a 2 in front of lithium chloride. That gives me 2 lithium. So I have to come back here and put a 2 in front of that. Okay? Everybody good with that one? Okay, how many people have done number 5? Okay, look at that one too then. Okay, so on number 5, I've got magnesium and fluorine. Okay, so this is an ionic compound, magnesium fluoride. Okay, and it's reacting with cobalt and nitrate. What's that one going to need? In the name. It's going to need Roman numerals. Cobalt has more than one possible charge. Okay, so nitrate's always a -1, and there are 3 of them. Okay, so there's 3 negative charges, so I've got to get 3 positives out of cobalt, so this is cobalt 3 nitrate. Okay, that's going to form magnesium nitrate, also an ionic compound, and cobalt 3 fluoride. Okay, why didn't I go through all of the rigmarole to figure out the 3 again? How did I know it was a 3?
Because fluorine has 1 charge.
Okay, partially that, and partially because I already figured it out, and it's not going to change types from one side of the reaction to the other. Okay, if I start out with cobalt 3, I end with cobalt 3. Okay, it's not going to change to cobalt 2 because it went in a chemical reaction. Okay, what kind of reaction is this? Double replacement, right? Okay. What should I balance first? I could choose fluorine or nitrate, either one. They're both 3s. Okay, it doesn't really matter which one I start with. Okay, but since fluorine's listed first, we'll go with that one. Okay, on this side there are 2 fluorine. On that side there are 3. The balancing number would be 6. Okay, so I'm going to put a 2 in front of it on this side and a 3 in front of it on this side. Now, when I put that 3 there, it gives me 3 magnesiums, so I need to go over here and make sure I have 3 magnesiums. Okay, that 3 now gives me how many nitrates? 6. Right. Okay, 3 times 2 is 6. This little 3 here doesn't matter. All right, so I get 6 nitrates, so I'm going to come back over here and make sure I have 6 nitrates. And by putting that 2 there, I also made the cobalt balance. All right, so now my reaction is balanced. Okay, how many people have done number 6? Okay, I'm going to give you a few more minutes on number 6. Okay, remember you got to write the formulas out, reaction type, and then balance. Right, so we give a few more minutes on that one. Okay, so as we said, this is the first one where we're going the other way. We have the word equation and we have to put it in formula form. Right, so I've got copper 2 nitrate. What does the 2 tell me about copper? Its charge, right? Its charge is 2 plus. Okay, and it's with nitrate, which is NO3, which is a -1. So I'm actually going to have CuNO3 2. Okay, that's copper 2 nitrate. Okay, it's reacting with magnesium, which is just Mg. Okay, it's reacting with an element. Okay, and it's going to form magnesium nitrate. So that'll be Mg, which is 2 plus, with nitrate, which we already said is a 1 minus. Okay, so we're going to MgNO3 and copper metal. Okay, so basically copper by itself. Okay, so that's what our formulas should look like. Okay, swapped and dropped correctly. Now, what kind of reaction is that? It's a single replacement reaction. Okay, and now I'll balance it. Done. Okay, I don't have anything to do for balancing here. I've got 1 copper on this side, 1 copper on the product side, 2 nitrates on the product side, 2 nitrates on the reactant side, 1 magnesium on both sides. That equation is already balanced. Okay, so tomorrow we're going to be working more on these word to formula type of equations. Okay, remember that your lab reports are due at the start of class tomorrow. So as you finish them up, submit them right away. Okay, so submit them before the start of class. If they're submitted after that, they're late, so make sure you have them submitted before the start of class tomorrow. Okay, and I'll get them marked and back to you and we can go over.